Every major breakthrough in artificial intelligence depends on something far more physical than code. Not talent, not clever algorithms, not hype. It depends on machines, power, and infrastructure. Frontier AI isn't floating in some abstract digital cloud. It runs inside industrial facilities. Massive data centers filled with specialized chips. Facilities that draw more electricity than entire towns. Buildings engineered for cooling systems that look closer to power plants than software startups. Training the most advanced AI models requires tens of thousands of high-end chips working in parallel. They consume enormous amounts of energy. They require custom networking. They require dedicated grid capacity. This isn't just software, it's heavy engineering. And that changes the conversation, because software can move, infrastructure cannot. Right now, only a small number of companies on Earth can physically operate frontier AI systems at scale. Not because of intelligence, not because of ideas, but because of infrastructure. Most advanced AI workloads run on the same handful of cloud providers, the same hyperscale data centers, the same chip supply chains. Even startups outside the United States often depend on American cloud infrastructure to train and deploy their models. Which means something important, even if talent moves, even if capital shifts. Infrastructure anchors power, and infrastructure doesn't move easily. In 2026, the race isn't just about building better models, it's about building better physical foundations. Meta and Nvidia have secured massive long-term chip supply agreements to guarantee future AI capacity. Entire regions are competing to build sovereign AI data centers. Countries like India are committing billions to expand domestic compute infrastructure in an effort to reduce dependence on foreign providers. These aren't symbolic investments. They are strategic moves to control where artificial intelligence can physically exist. Because training a frontier model isn't like launching a website. It requires gigawatts of stable electricity, advanced cooling systems capable of managing extreme heat loads, high-density server racks drawing multiple times the power of traditional infrastructure. Electric grids are being redesigned to accommodate AI demand. Energy policy is shifting. Industrial zones are being repurposed to house data clusters. In some cases, companies are building off-grid solutions to power AI operations independently. This is not theoretical, this is industrial, and it creates a new map of AI power. The countries that win in AI may not be the ones with the most engineers. They may be the ones with the cheapest and most reliable energy, the ones with available land, the ones with chip supply agreements, the ones capable of building infrastructure faster than everyone else. Talent matters, capital matters, but scale depends on something heavier. Infrastructure determines how quickly a model can be trained, how fast it can be deployed, how widely it can be distributed. If you don't control the compute layer, you rent it. If you rent it, you operate under someone else's constraints. This is why the global AI race increasingly looks less like a startup competition and more like an industrial expansion. New AI hubs are forming where power grids can support them, where regulatory approval is predictable, where hyperscale construction can move quickly. And this is why even countries with deep technical talent still struggle to compete at the frontier. Because frontier AI is not limited by intelligence. It is limited by physical capacity, by energy, by silicon, by steel and concrete. This changes how we think about control. When people ask who controls artificial intelligence, they often look at founders or CEOs. But the deeper layer is this: who owns the machines that make intelligence possible? Who owns the data centers? Who secures the chip supply? Who controls the energy flow? Because that is where scale lives. And scale is what separates experimentation from dominance. Infrastructure is slow to build. It requires long-term capital. It requires coordination between private companies and governments. It It requires vision beyond quarterly returns. Which means the next decade of AI competition will not just be fought in labs, it will be fought in construction zones, in energy markets, in supply chain negotiations, and in the quiet decisions about where intelligence is physically allowed to live. So when we talk about AI power, we shouldn't only ask who is building the smartest models. We should ask who is building the foundations, because infrastructure decides who scales, and scale decides who wins. In the next episode, we move one layer deeper into this power structure. If infrastructure anchors artificial intelligence, then what about the financial layer beneath it? What happens when companies don't actually own the money they appear to control? That's where the next part of this story begins.